Morning, everybody. I wanted to record a hopefully quick video explaining the notes that I'm about to post on properties of equality. So I'm giving you all these notes right here. You're gonna, semi-memorize some of them, but I wanted to just go through and kind of talk about what they are and how they're gonna work and how we're gonna use them, in class. So the first four: addition property, subtraction, uh, subtraction, not subtractions, addition property, subtraction property, multiplication property, division property. These are all just algebra. So these little descriptions here aren't exactly the most intuitive, but for instance, it says, if A equals B, then A plus C equals B plus C. What they mean is if I had X minus 2 equals 4, then you would do the same thing to both sides to keep them equal. But I want to know what X equals, so I want to get it by itself. So you would add 2 to both sides. So if you consider this is A and this is B, then A plus C equals B plus C. And that's exactly what we're going to get. We're going to get X equals 6. So these first four are just explanations, literal explanations of how you do algebra. If you add to both sides, it's addition property. If you subtract from both sides, if you multiply both sides, if you divide both sides, then it's those four properties. That's basically all of algebra, frankly. But we're not in algebra. We are in geometry. And geometry at times can be difficult, and this is one of the things. So let's look right here. I put a star next to reflexive property because it is the most forgotten thing in geometry. So many students forget about the reflexive property. But let's say, I don't want to do this. Nah. I have a better idea. All right. Let's draw this. So let's say, and you won't have to do this anytime soon, but you will have to do it in the future. Let's say that you are trying to prove that these two triangles are equal. This is 100% a thing you're going to have to do later. Not right now. So what the reflexive property of equality is saying is that, this little indication here, this A equals A, is redundant, right? Of course A equals A, it equals itself. What they mean is that if we have a situation like this, where I'm trying to prove that this triangle is equal to this triangle, they share a side. And what the reflexive property allows you to do is say, well, AB is equal to itself in both triangles. So it's equal in both triangles. I know it's a little confusing right now. It'll make sense in a little bit. But proofs are written in this 2-column format, right? You're going to have your statements on the left side and your reasons on the right. Normally, statements are the math, reasons are the words, the explanations. You would write all of these properties on the right side. So I'll give you an example in just a little bit. But reflexive property of equality would look like this in this instance. You would have AB equals BA. And then there would be a column, a literal line, right? And I'll draw the whole thing out. It's normally going to look like this, and I will talk more about it in a little bit, but I figured I would just explain these notes. You'd have statements here and reasons here. So in this picture, you're saying that AB equals BA, and your reasoning is reflexive property. Did I spell it right? Reflexive, yeah, property. Use prop for short. The spelling of this is regretfully important. Reflexive property is the property, but reflective is not a property, but they will 100% put that on their test. I've seen that every single year since I've been a teacher. They put reflective property on a test. Don't fall for it. It's a dirty trick. It's reflexive. But we won't be using reflexive property for a long time, which is probably why most students forget about it. But for now, just understand. And there's a star next to it because I really want you to remember it because it's gonna be very important. Okay. So moving on, I'm gonna keep the statements and reasons here because this is important. Symmetric property is pointless. It's pointless. If A equals B, then B equals A. Basically, you can flip any equation you have around the equal sign so long as you keep everything where it's supposed to be. So, 2x plus 5 equals 459y plus 2, right? That's the same exact thing as saying 459y plus 2 equals 2x plus 5. Well, we'll use this as an example to explain this. So let's say you were given this as your statement. And I say given because you were literally given it. That is a reason for knowing information. If the information was flat out given to you, then your reason is given. Let's say we wanted to move it to here. So we flipped this. If that's the case, your reasoning, how you went from this step to this step, is symmetric property. That's how we're going to be doing proofs. Is you've got your statements on the left, your reasons on the right, the information you were given, and then how did you move from here to here? How do you go from here to here? So on and so forth. All right. So transitive property and substitution are almost, all right, they're exactly the same. There's no difference between them. The nice thing is that your test makers understand that and don't expect you to ever know the difference between these two. So substitution is the more commonly used property. It's the one you're going to see most in proofs and using. Sometimes, if you're given like a pre-filled out one and you have to fill in the blank, sometimes they'll give you like transitive property. All you have to know is that these two are exactly the same, and you're going to use substitution more. So an instance of substitution would be, let's say x equals 5. And you were given this information. And then let's say you were given 2x plus 2 equals 12. In a proof, you have to explain every single thing you do. Everything you do has to be explained. It's kind of like if you were teaching the subject to like an 8-year-old or a 10-year-old sibling, or it's like, you have to go through every little thing. That's what you're doing in a proof, and you have to have a reason for everything you do. So how do we make x 5? Well, these are our reasons. I like substitution more as an explanation. They're exactly the same. Transitive property and substitution are the same. Because x equals 5, then every x that I know in the confines of this equation can become 5 through substitution. And every 5 can become x. So this can be 2 times 5 plus 2 equals 12. And your reasoning would be substitution property. Substitution property. And then, of course, yeah, 12 equals 12. All right. And then the last thing I will do is an example algebraic proof before, I give you essentially your actual work. So we got our statements and reasons. Let's say I gave you, let's say 3x all right. You were given this, right? Normally what will happen is you'll be given, it'll say given, and we've got 3x plus 15 equals 45. This is normally how proofs are done. You're automatically given the very last statement. You have to figure out how to go from here to here and explain every step. It's not about solving anymore, it's about the explanation. So we're going to go through this together. Since it's algebra, it's only going to be the first four, and that's all we're going to really focus on the next quiz is the first four in algebraic proofs, because significantly easier geometric proofs are going to be a pain, but we'll get to that. So we got 3x plus 15 equals 45. That was our given. It was literally given to us. It's the only thing I can write as a given. The only reason that is given is anything next to given. I'm going to repeat myself because I see this all the time. I will get a proof by students that say given, 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 proved. And oh my goodness, oh my God, the rage. So one, there's no reason called proof, proved, or proof. Those aren't reasons. That's not a thing you can write down as like, hey, this justifies my answer. That's literally like going to your mom and saying, why does this happen? And she going, because. It gives you nothing. It does nothing. So let's not do that. So let's go through this. You do not show your work in a proof. You just go from one step to the next. So if I did that, I would just have 3x equals 30. So what did I do to both sides? Well, there was a 15. Now there's a 15 missing from the left side and 15 less from 45, which means I used subtraction property. And then the last step, if I got rid of this 3 on the x, I would just be left with x equals 10. And oh my goodness, that's what we were trying to prove. So now all we have to figure out is how did we go there? Well, what did I do to both sides? There was multiplication here. I do the opposite to both sides. I divided them. So division. And that's it. That's an algebraic proof in its finality. What you are trying to prove will always be your last statement. The reason can be a lot of different things, but the last statement is always what you are trying to prove. And then your first couple of statements are what you've been given. So I promise you the algebraic proofs are going to be very easy. You're going to be just using these 4. And some of you are going to be like, oh, this is so easy. What does he mean this is the hardest chapter? Yeah, no, they introduce geometric proofs so early because you normally need the entire year to get somewhat good at them. And we'll be doing them constantly. So, but we'll start off easy, especially since the end of the semester is coming up. The end of this 9 weeks is next Friday. So any work you get done before next Friday will be counted towards the first 9 weeks grade. But we will talk about that more in a message. Until then, you guys all have a wonderful day.